Welcome to 3 Inquisitive Kids. In this video, we will be solving a problem using the mathematical induction. Here's our problem. N is a natural number, and 2 to the n plus 2 power plus 3 to the 2n plus 1 power must be a multiple of prime number, and we have to solve this problem in 2 steps. First step is, what is p? And second, how do you prove your answer? Let's see what happens when n is equal to 1. When n is equal to 1, we have 2 to the third power plus 3 to the third power, which gives us 8 plus 27, which is the same thing as 35. Okay, so 35 is the product of 2 prime numbers, 5 times 7. So this prime number p could either be 5 or 7. But then let's try out what happens when n is equal to 2. Because we have to guess what p is. When n is equal to 2, we have 2 to the 4th power plus 3 to the 5th power. And this is equal to 16 plus 243, which gives us 259. 259 can be broken up as it must be divisible by either 5 or 7. And because it's not divisible by 5, it must be 7 times, 37. So as you can see, p must be 7 because 7 is a prime number that appeared in both of these scenarios. So we can guess that p is equal to 7. But then we have to use mathematical induction to prove it. So then how can we do that? Well, we can assume that when n is equal to k is an integer, 2 to the k plus 2 plus 3 to the 2k plus 1 is equal to a multiple of 7. So let's say 7t. And k is that is our assumption, that when n is equal to k, this statement holds true. So then we have to prove what happens when n is equal to k plus 1. When n is equal to k plus 1, we can just rewrite this equation, but replace every single n with k plus 1. 2 to the k plus 1 plus 2, k plus 3 power, plus 3 to the 2 times k plus 1 plus 1 power is equal to 7t. All we have to do is just look at the left side of this equation. So on the left, we have 2 to the k plus 3 power plus 3 to the 2k plus 3 power. And this 3k plus 3 can be rewritten as 3 to the 2k plus 1 times 3 to the second power. Here, we can just isolate 3 to the 2k plus 1 by itself. So we know that 3 to the 2k plus 1 power is equal to 7t minus 2 to the k plus 2 power. We just move this 2 to the k plus 2 power to the right side of the equation. So then over here, we can rewrite it as 2 to the k plus 3 power plus 7t minus 2 to the k plus 2 power times 3 to the second power. Because look, this 3 to the second power came over here, and this 3 to the 2k plus 1 power, we rewrote it like this. Now we can use the distributive property. We have 2 to the k plus 3 power plus 63t minus 2 to the k plus 2 power times 9. And we can simplify this a little bit. And we can simplify this a little bit. 63t, we can factor out a 2 to the k plus 2 power. So we have 2 after we factor it out from here, minus 9 after we factored it out from here. Which means now we're left with 63t plus 2 to the k plus 2 power times negative 7. And we can factor out a 7 here to get 9t minus 2 to the k plus 2 power. So as you can see, we're left with 7 times something else, which means that this is a multiple of 7. So we have proven that when n is equal to k plus 1 and when n is equal to k, 2 to the k plus 2 power plus 3 to the 2k plus 1 power is a multiple of 7.